Bismillahirrahmanirrahim. Assalamu alaikum. I'm Sarmad Sagir. The topic which we're going to discuss today is formic acid. The definition of formic acid is formic acid is the simplest carboxylic acid containing a single carbon, occurs naturally in various sources, including the venom of bees and ant stings, and is a useful organic synthetic reagent, principally used as a preservative and antibacterial agent in livestock feed. What actually is formic acid? Formic acid is a colorless liquid having a pungent, penetrating odor at room temperature comparable to the related acetic acid. It is miscible with water and most polar organic solvents and is somewhat soluble in hydrocarbons and in the Weber phase. It consists of hydrogen bonded dimers rather than individual molecules. Owing to its tendency to hydrogen bond, gaseous formic acid does not obey the ideal gas law. Solid formic acid, which can exist in either of two polymorphs, consists of an effectively endless network of hydrogen bonded formic acid molecules. Formic acid forms a high boiling azeotrophs with water 22.4%. Liquid formic acid tends to supercool. The natural occurrence of formic acid. In nature, formic acid is found in most ants and in stingless bees of the genus Oggetrigona. The wood ants from the genus Formica can spray formic acid on their prey or to defend the nest. The pus moth caterpillar will spray it as well when threatened by predators. It is also found in the trichomes of stinging nettle. Formic acid is a naturally occurring component of the atmosphere primarily due to forest emissions. Now we're going to talk about production of formic acid. In 2009, the worldwide capacity for producing the formic acid was 720,000 tons, 1.6 billion pounds per year, roughly equally divided between Europe 350,000 tons or 770 million pounds, mainly in Germany, and Asia 370,000 tons or 820 million pounds, mainly in China, while production was below 1,000 tons or 2.2 million pounds per year in all other continents. It is commercially available in solutions of various concentrations between 85 and 99% rate of weight. As of 2009, the largest producers are BASF, Eastman Chemical Company, LC Industrial, and Feecheng Acid Chemicals, with the largest production facilities in Ludwigshafen. 200,000 tons or 440 million pounds per year, BASF Germany. AULU 105,000 tons or 230 million pounds, Eastman Finland. Nakhon LC Industrial and Feecheng 100,000 tons or 220 million pounds, Feecheng China. 2010 prices range from around 650 pounds per ton, equivalent to around $800 per ton. In Western Europe to $1,250 per ton in the United States. Uses of formic acid. The major use of formic acid is as a preservative and antibacterial agent in livestock feed. In Europe, it is applied on silage, including fresh feed. In Europe, to promote the fermentation of lactic acid and to suppress the formation of butyric acid, it also allows fermentation to occur quickly and at a lower temperature, reducing the loss of nutritional value. Formic acid arrests certain decay processes and cause the feed to retain its nutritive value longer, and so it is widely used to preserve winter feed for the cattle in the poultry industry. It is sometimes added to feed to kill E. coli bacteria. Used as a preservative for silage and other animal feed constituted 30% of the global consumption in 2009. Formic acid is also significantly used in the production of leather, including tanning, 23% of the global consumption in 2009, and dyeing and finishing textiles, 9% of the global consumption in 2009. Because of its acidic nature, used as a coagulant in the production of rubber consumed 6% of the global production in 2009. Formic acid is also used in place of mineral acids for various cleaning products such as limescale remover and toilet bowl cleaner. Some formic esters are artificial flavorings and perfumes. Beekeepers use formic acid as a miticide against the tracheal mite and the varroa destructure mite. Formic acid application has been reported to be an effective treatment for warts. Formic acid can be used in a fuel cell. It can be used directly in formic acid fuel cells and indirectly in hydrogen fuel cells. It is possible to use formic acid as an intermediary produce isobutanol from carbon dioxide using microbe. Formic acid has a potential application in soldering. Due to its capacity to reduce oxide layers, formic acid gas can be blasted at an oxide surface in order to increase solder workability. Formic acid is often used as a component of mobile phase in reverse phase high performance liquid chromatography analysis and separation techniques for the separation of hydrophobic macromolecules such as peptides, proteins, and more complex structures, including intact viruses, especially when paired with mass spectrometry detection. Formic acid offers several advantages over the more traditionally used phosphorus acid. This is the chemical structure of formic acid. Now we're going to talk about the bonding of formic acid. The formic acid molecule contains a total of 4 bonds. There are two non-H bonds, one multiple bond, one double bond, one carboxylic acid, and one hydroxyl group. Chemical properties. Formic acid is a low flammable, biodegradable, and stable liquid under ambient conditions with a boiling point of 101 degrees centigrade and a freezing point of 8.3 degrees centigrade. It is a colorless, clear, and corrosive liquid with a pungent odor. Other properties of formic acid are also favorable for the use as an LOHC. Formic acid is a low flammable, biodegradable, and stable liquid under ambient conditions with a boiling point of 101 degrees centigrade and freezing point of 8.3 degrees centigrade. It is a colorless, clear, and corrosive liquid with a pungent odor. Thank you very much.